Good morning, friends. I am Dr. R.S. Bhat, Ravi Shankar Bhat, Professor, Department of Mathematics, MIT Manipal. In this presentation, I am going to talk about normal distributions. Let x be a continuous random variable with mean mu and variance sigma squared. We say that the random variable x has a normal distribution. The PDF of x is given by f of x is equal to 1 by sigma root of 2 pi e power minus half into x minus mu by sigma whole square. X ranges from minus infinity to plus infinity. In this root of 2 pi, the root stands for both 2 and pi. If the random variable x has normal distribution with mean mu and variance sigma square, then we write it as x has n of mu sigma square. Read it as x has normal distribution with mean mu and variance sigma square. It is also called Gaussian curve or Gaussian distribution, as the distribution is invented by the mathematician Gauss. Standard normal distribution, we say that x has standard normal distribution if x has n of 0, 1. That is, mean mu equal to 0 and variance sigma squared is equal to 1. Substituting these values in equation 1, we get the PDF of standard normal distribution as, so when mu is equal to 0 in equation 1 and sigma is equal to 1, it becomes x squared by 2. So my PDF becomes f of x is equal to 1 by root of 2 pi e power minus x squared by 2. X ranges from minus infinity to plus infinity. The shape of standard normal distribution curve is bell shaped as shown in the figure below, which has peak at x equal to mu equal to 0 and flattens after x equal to 3 and x equal to minus 3 and grazes x-axis. It is observed that the area bounded by the curve from minus 3 to plus 3 instead of minus infinity to plus infinity, the total probability is approximately 1 as f of x is the PDF. The positive x-axis acts as tangent at infinity and negative x-axis is tangent at minus infinity. The curve is symmetrical about y-axis and hence area bounded by the curve to the left of y-axis is equal to area bounded by the curve to the right of y-axis. If x has n of 0, 1, then probability of x less than or equal to a may be written as phi of a, which is equal to integral minus infinity to a 1 by root of 2 pi e power minus x square by 2 dx, which is equal to area bounded by the curve to the left of x equal to a. Similarly, probability of x lying between a and b may be written as phi of b minus phi of a, upper limit minus lower limit. The values of this integral for different values of a are calculated using gamma functions and tabulated in a table called normal distribution table. The normal curve is shown in the figure. Theorem 1. If x has n of mu sigma square, then z is equal to x minus mu by sigma has n of 0, 1. The above theorem gives a method to convert a random variable x with any mean mu and variance sigma square to standard form. How to refer normal distribution table? In the table supplied, the values start from 0, 0 and end in 3.1, 3.9. In the first row, 0.00 to 0.09. So if we need to find probability of x less than or equal to 2.5, which I call it as phi of 2.5, then we need to refer the value of 2.5 row intersecting with column 0.00, which is found to be 0.9938. Similarly, probability of x less than or equal to 1.75, which is equal to phi of 1.75, is 0.9599, which is the intersection of row 1.7 and column 0.05. Similarly, you can find probability of x less than or equal to 1.5, probability of x less than or equal to 0.78, probability of x less than or equal to 2.96 for practice. So here is the normal distribution table. So if you want to find 2.5, probability of x less than or equal to 2.5, then you, in the first column, you go to 2.5, yeah, it is here, and 0 column. So its intersection is 0.9938. That is how this value is obtained. If you want 1.75, 1.75, so 1.7 row wise, and in the column you have to go to 0.05, 0.0. So this is 9599. That is how to refer the table. Note that the table gives probability only for positive values. To find the probability for negative values, we use following rule of CDF discussed earlier in the class. If phi of x is the CDF of x, then phi of minus x is equal to 1 minus phi of x, which is the property of CDF. So phi of minus 2.5 may be written as 1 minus phi of 2.5, and phi of 2.5 can now be referred from the table, which is known to be 0.9938, and answer is 0.0062. Let's go take a problem. Suppose x has n of 516. Find probability of mod x less than or equal to 1. Here it is given that x has normal distribution, mu is equal to 5, sigma squared is equal to 16. Therefore, sigma is the standard deviation, is equal to positive square root, which is equal to 4. We have probability of mod x less than or equal to 1 is nothing but the interval x lying between -1 and +1. Therefore, I can write probability of mod x less than or equal to 1 as probability of x lying between -1 and +1. Now we change this to standard form using theorem 1. What I do is I subtract mu and divide by sigma throughout the inequality. So we have probability of -1 minus mu by sigma less than or equal to x minus mu by sigma less than or equal to 1 minus mu by sigma. Now I substitute the value of mu and sigma, and I can substitute x minus mu by sigma as z. So z lies between minus 1.5 and -1. Now probability of z lying between a and b can be written as phi of b minus phi of a, because z has standard normal distribution. And b is -1 in this case, a is minus 1.5, so it becomes phi of -1 minus phi of minus 1.5, which is equal to 1 minus phi of 1 minus 1 minus phi of 1.5. Here you have to open a bracket. It is phi of 1.5 minus phi of 1, and phi of 1.5 is 0.9932 from the table. Phi of 1 is found to be 0.843 from the table, and the answer is 0.1514. 0.19. Let's go to the next problem. The mean and standard deviation obtained by 1000 students in an examination are respectively 34.4 and 16.5. Assuming the normality of the distribution, find approximately number of students expected to obtain marks between 30 and 60. Solution. Here mu is given to be 34.4 and sigma is given to be 16.5. We need to find the probability of x lying between 30 and 60. Changing to standard form, as in the previous problem, we subtract mu divided by sigma throughout. So probability of 30 minus mu by sigma is less than or equal to x minus mu by sigma is less than or equal to 60 minus mu by sigma. Calling x minus mu by sigma as z. So z lies between 30 minus 34.4 divided by 16.5, which is less than or equal to 60 minus 34.4 divided by 16.5, which reduced to probability of z lying between minus 0.266 less than or equal to 1.55. And referring to the table, phi of 1.55 is 0.9394 and phi of minus 0.26 is 1 minus phi of 0.266, and the value phi of 0.266 from the table is 0.6026. So the final answer is 0.5426. Therefore, the number of students taking marks between 30 and 60 is equal to 1000 into the probability, which gives the number of students approximately equal to 543 students. Suppose phi of a is 0.5, then we can write a equal to 0, since by referring to the table phi of 0 is 0.5. This is called referring the table in the reverse order. Similarly, if phi of a is 0.9744, then a is 1.95. How we got this? Refer the table in the reverse order. First search for the value near to 0.9744 inside the table, which is the intersection of the row 1.9 and column 0.05. Therefore, phi of 1.95 is 0.9744, hence A is equal to 1.95. This technique is used in the next problem. Let's go to the third problem. In certain examination, the percentage of candidates passing and getting distinctions were 45 and 9 respectively. Estimate the average marks obtained and standard deviation of marks, if the minimum pass and distinction marks being 40 and 75 respectively. Solution. Since the minimum mark to pass is 40 and it is given that 45% students have been passed, we can write it as probability of x greater than or equal to 40 is equal to 0.45, because all those students getting more than 40 will pass, so they will be in the 45% range. That is, probability of x less than 40 is, so taking the complement we get is 0.55. Now changing to standard form, I get probability of x minus mu by sigma is less than 40 minus mu by sigma, which is 0.55. This implies phi of 40 minus mu by sigma is 0.55, and referring the normal distribution table in the reverse order, we have 40 minus mu by sigma is equal to 0.13. What is obtained? Refer the table in the reverse order. First search for the value near to 0.55 inside the table. which is found to be 0.5517. So if exact value 0.55 is not found, we find the nearest value, which in this case it is 0.5517, which is the intersection of row 0.1 and column 0.03. Therefore, this value is 0.13. Then 40 minus mu by sigma is equal to 0.13. Therefore, I can write mu plus 0.13 sigma is equal to 40. Again, since all students with marks more than 75 get distinction, and distinction being 9%, we have probability of x greater than or equal to 75 is 0.09. That is, probability of x less than 75 is 1 minus 0.09, which is 0.91. Changing to standard form, probability of x minus mu by sigma is less than or equal to 75 minus mu by sigma, which is equal to 0.91. Referring the table in the reverse order, we have 75 minus mu by sigma is 1.35. Hence, we have another equation, mu plus 1.35 sigma is 75. Solving the equation 1 and equation 2, we get mu is equal to 36 and sigma is equal to 28.68. Therefore, the average mark scored by the student is 36 and the standard deviation is 28.68. Thank you.